In today's lesson, we're going to look at analyzing graphs, and specifically, we're going to look at end behavior and extrema. So starting out with end behavior, you've got spots where I'm going to show you, we're going to be able to look at end behavior based on just a function and based on a graph. I actually want to discuss the graphs first. So I'm just going to sketch a graph. So don't worry about exact points. Let's just say we have a parabola. And we're talking about end behavior. So end behavior is basically as x approaches, so an arrow in math is the word approaches, as x approaches infinity, so as x is going forever and ever this way, what are our y values doing? So as x approaches infinity, y, or we would say f of x, what is f of x approaching? Well, in a parabola, as x approaches infinity, our y values are also approaching infinity. All right, and now the other direction. We want the end behavior both ways. So as x approaches negative infinity, what are our y values doing? Our y values, well, in this case, they're also approaching positive infinity. All right, so here's just a quick sketch of another graph. This would be an exponential function. So exponential function, they all start the same. So as x approaches infinity, as x goes forever and ever this way, this exponential function, you should remember, oh, that's an asymptote. It will never hit zero, never cross zero, but it will forever approach zero. So as x approaches infinity, f of x approaches zero. And then the other way, as x approaches negative infinity, the y values approach positive infinity. All right, and the last example, it's just a quick sketch, but I'm going to put a horizontal asymptote at 3. And let's say we've got this function here, this graph. Okay, so I'm just going to kind of write on top of my graph, but as x approaches positive infinity, as we're going this way, the y values approach the asymptote. They approach 3. And other direction, as x approaches negative infinity, f of x approaches also the horizontal asymptote, just from the other direction. So they both approach 3. So now what we're going to do is look at how to determine this information if we don't have a graph and all we have is a function. So I'm going to first just write down all 3 functions we're going to look at, and we're going to kind of compare them. So f of x equals x to the 4th plus 1 over x. F of x equals x over x to the 3rd plus 1. And f of x equals 2x plus 1 over 3x minus 7. So the first thing I just want you to notice are the degrees. This first one, I have a higher degree in my numerator than I do in my denominator. The second one, it's opposite. I have a higher degree in my denominator than I do in my numerator. And the last one, they have the same degree. So that is the information we're looking for to describe our end behavior. So for all of these, as x approaches positive infinity, and then all of them we're going to look as x approaches negative infinity. Okay, so let's just start with this first one. If you are going to, I want you to picture plugging in infinity to the fourth power over infinity. Okay, infinity is a concept and not a numerical value, so this is not technically good math to write that. But I just want you to visualize, if you're putting a really, really large number and raising it to the fourth power, and then dividing by, it's a large number, but it's not going to be as big as the numerator. And because both of these are going to be positive, you're going to keep getting a larger number and larger number because it's so much bigger in the numerator. So as x approaches infinity, y, or f of x, will also approach infinity. But now let's look at the second one. As x approaches infinity, so now I have infinity in the numerator, but infinity to the third power in the denominator. I'm going to have a much larger number in the denominator. So if I'm dividing by a very, very large number, that number is getting closer and closer to 0. So y is approaching 0. All right, now let's do negative infinity for both of these. So this first one, so think negative infinity, but raised to the fourth power. Well, that's going to be positive over negative infinity is negative, and a positive divided by a negative is a negative. So y will approach negative infinity for this one. All right, now for the next. If you plug in negative infinity and then negative infinity to the third, that will be a negative divided by a negative, which will be a positive. So this one, as x approaches negative infinity, y will approach, actually this one, it doesn't really matter that it's, so two negatives make a positive, but for this one it's still going to be 0. But I still just want you to, you have to consider that in some of the questions. Okay, now this last one. If they have this, like the same degree, they're going to be growing at a pretty close rate. But what we can do is anytime you have the same degree, we don't care about these numbers, we care about this coefficient. So as x approaches infinity, y is going to approach that quotient 2/3. And it is going to be the same on the other direction. So as x approaches negative infinity, y will also approach 2/3. So bigger number on top, we've got our infinity. Bigger number on the bottom, we've got 0. And if it's the same, you look at the leading coefficients. Okay, so now instead of end behavior, we're looking at extrema, our extreme values. So I just want you to sketch this graph. Doesn't have to be exact. We're going to go up, we're going to go down, back up, and then down. So this top point is our absolute max, absolute maximum number, because that is the greatest value over the entire domain. Now, we do not have an absolute minimum because it's going to negative infinity in both directions. We don't have a smallest number, but so absolute extrema, the definition is just the greatest or least value over the entire domain. So the whole graph. It's basically just the top number, the smallest number over the entire graph. Now, relative extrema, we're looking at relative min and relative max. Well, if here, this is what we call a relative min, and this right here is a relative max. So So this is greatest or least value, but within some interval. So it's not the top number, but hey, it is, it's the top number within a certain interval. So absolute max, absolute min, relative max. All right, now we're going to look at finding the values of maybe our absolute or relative min and max on our graphing calculators. So we're going to use this function, f of x equals negative 4x to the third minus 8x squared plus 9x minus 4. So grab a graphing calculator. All right, so I go into my y equals and I'm going to type in this function. Okay, I'm going to graph. And it looks like I don't have my full graph, so I'm going to hit zoom and I'm going to zoom out. Hit enter. I don't love that graph, so I'm going to go play with my window. All right, so in my window, I adjusted my x values are ranging the -5 to 5. Now I have a pretty good graph. So I don't have an absolute max or an absolute min, but I'm going to find my relative min. So let's just back up a little bit. So here's my graph. What I did is I hit second trace. So I'm calculating. I'm going to calculate a minimum. Now, see how it says left bound? I'm going to move my cursor left of that minimum point and hit enter. And now it says right bound. I'm going to move it to the right, hit enter, and hit enter again. So here it gives me the x value and the y value. So I'm going to write that down. There is a relative min, and it's a relative min of y is equal to -22.8, and that is at the x value at -1.76. Okay, so now second trace, I'm going to calculate maximum. Same thing, left bound. So this maximum point I want left of that. Hit enter, right bound, find a right one, enter, enter again, and there it found the maximum value. So there is a relative max and the y value, so relative max of y equals -1.93, and that is at the x value 0.43. Okay, there is your full lesson on end behavior and extrema. Good luck.